Welcome back to section 5 of chapter 1. In this section, we're going to be looking at solving equations by graphing. We'll see how to do it graphing by hand and also how to do it using technology. So today, our learning targets, I can use graphs, tables, and graphing technology to find or approximate solutions to equations and inequalities. Then I can find approximate solutions to equations and inequalities by setting each expression equal to y and graphing. So our first one, I know it's way up here in the corner. That's because we're going to have a big graph. When you're graphing to solve, you want to use graph paper. Otherwise, it's not going to be accurate enough to get much of an answer. So we have negative 3x plus 20 equals 5. We have a graph here. And you might be asking yourself, why am I solving this by graphing? Why don't I just subtract 20 and divide by negative 3 to find the solution? And the answer is yes, that's how you would generally solve this one. We're starting out with this one so that we can see the conceptual part with a pretty easy problem that we can find the answer to. So when we graph, we're going to split it at the equal sign. We're going to say y equals that side and y equals that side. So we have y equals negative 3x plus 20. It's a line. We're going to start out at our y-intercept at 20, and we're going to go down 3 over 1. Now there you might be thinking like, wait a second, we're counting by twos, which is true. We're counting by twos in both directions though. So I didn't technically go down 3 over 1, I went down 6 over 2, but that's the same thing. That's what's nice about having the same scale on your x and your y axes. It is not essential, but if you do, then you can count boxes. And so we can go down another 3 boxes over 2, get a point, and then connect this with as straight of a line as I can manage. That looks about right. All right, and then we can graph the y equals 5. So that's going to be right about halfway up. And we can go sideways. There we go. And what we're looking for is this intersection point. Specifically, we are looking for the x value at that intersection point. The y value doesn't have a whole lot of meaning here because there was no y in the original equation. It was just x's. We just made them equal to y. That way, when the y's equaled each other, they intersected, we could solve the equation. So here we're looking at the x value. And it looks down here like maybe x equals 5. Now, when you're solving by graphing, it's always just a guess. The better your graph is, though, the better your guess should be. This looks like 5. Let's plug that in. Negative 3 times 5 plus 20 equals 5. Let's see, negative 3 times 5 is negative 15. Plus 20 is 5 equals 5. Does 5 equal 5? Yes, it does. So x equals 5 is our answer here. Now we can go to something that's going to be a little bit more difficult to solve algebraically. We could have easily solved the other one algebraically. This one we could solve algebraically. Either x minus 4 equals 1 half x plus 1, or x minus 4 equals negative 1 half x minus 1. We could do it, we'd have to solve both, and then it's possible we'll get answers that don't actually exist. We're going to solve it by graphing anyway. So let's get our graph. We're going to graph each side separately. We can do our y equals the absolute value of x minus 4. A couple ways we could do this. We could make a table and start plugging in values. Or we could think back to a couple lessons ago when we were looking at transformations. This is an absolute value, and then x minus 4, that translates it 4 to the right. So our vertex is at 4, 0. We haven't adjusted the slope because there's no horizontal or vertical stretches, and so the slopes will still be 1 and -1. So we can make there, and our -1 slope to make that V shape for the absolute value. And then we can graph the other one. Y equals 1/2 x plus 1. We start out at our y-intercept, and then our slope takes us up 1 over 2. Oh, that's an intersection point. Up 1 over 2. Now, it's important to keep going because if you look at this, it's going to intersect in 2 different places. It's going to intersect. I messed up my line there a little bit. Up 1 over 2, up 1 over 2, up 1 over 2. There we go. We're going to go up like that. So we intersect in a couple different places. It looks like we have here where x equals 2, and over here where x equals 10. We can plug them in to check and be sure. So plug in x equals 2, we're going to have absolute value 2 minus 4 equals 1/2 times 2 plus 1. 2 minus 4 is -2. Absolute value of -2 is 2. Equals, let's see, 1/2 times 2 is 1, plus 1 is 2. 2 does in fact equal 2. Plug in 10, get absolute value 10 minus 4 equals 1/2 times 10 plus 1. 10 minus 4 is 6, absolute value of 6 is 6. 1/2 times 10 is 5, plus 1 is 6. That's not a 6, that's a 5. There we go, 6. Does 6 equal 6? Yes, it does. So x equals 2 and x equals 10 are both solutions here. Now, if you were doing this algebraically and there was only one solution, it's possible it would actually give you 2 solutions and you'd have to cancel one of them out. So sometimes graphing is very beneficial to give you that visual of what you're looking at. We can look at inequalities as well. Here we have x squared minus 4 is greater than 0. So we can graph that quadratic, y equals x squared minus 4. Well, that, again, transformations, that's just 4 down with our x squared. So our vertex will be 4 down. And then with a quadratic, with no number in front of that x squared value, we're going to go over 1 up 1 in both directions. Then from there, we'll go over 1 up 2, or up 3, I mean. Then from there, we'll go over 1 up 5. Next number in the pattern, 7, we're going up by the odd values. If we did have a number in front of that x squared, say 2, we would just multiply those by 2. We multiply by whatever number's there. So if it was 2, instead of over 1 up 1, over 1 up 3, we go over 1 up 2, over 1 up 6, then over 1 up 10. So that's a little trick to help graph those quadratics a little bit easier. And we can sketch our quadratic. That one wasn't too bad. When you sketch your quadratic, make sure you're rounding that vertex. It should not be a point. I get it that you guys are not artists, neither am I, but do try to round it. When we get quadratics that are stretched vertically a bit, like a 5x squared, it gets harder and harder to make that round, but still try. So we have that one, and then the other line, y equals 0. Well, that's just the axis right here. And so now we want to know, when is the quadratic bigger than that 0 line? Well, it's bigger over here, and it's bigger over here. So it looks like it intersects right here at -2. So we want y less than -2, and then also y is greater than this +2 value over here. And it's not equal to because we want greater than 0, so we want it to be positive. If it was greater than or equal to 0, those two signs would have or equal to's on them as well. But it's just greater than. If we were looking for when is or when is x squared minus 4 less than 0, we would have done the exact same thing, but we would have been looking for this spot in the bottom. And it would have been negative 2 is less than y is less than 2. It would have been that middle part. So it doesn't matter which way the sign is going. You still do the problem exactly the same. It's just what are you looking for at the end that's the question. All right. This next one, the Desmos was supposed to fade in. We have x squared minus 4x plus 1 equals x minus 2. This is a bigger problem. This one, if you look at the directions, will probably say solve by graphing using some sort of technology, a graphing calculator, graphing software. Somehow it's going to have you use technology. So this one, I'm choosing to use Desmos so we can see how we use Desmos. Desmos is nice because everybody has access to it. Uh, it's a free website that has a graphing calculator and a whole bunch of other stuff. Um, the next problem we're going to see using a graphing calculator. Graphing calculators are nice because you can actually use them on tests, including AP tests, SATs, all sorts of tests. So it's nice to be able to use both. They both have their benefits and downsides, and um, they work the same, but sometimes the functionality, like the interface is different, but you can do the same thing each way. So for Desmos, we just go to desmos.com, and then there's this open graphing calculator button right here in the center. I'm trying to play this video that I have. I can't actually use Desmos. Oh, there it goes. I have to like film this part of it separate and then put it into the slideshow. So we go to the graphing calculator button. And then here, my internet lagged a little bit. There we go. Now over here on the left-hand side, we're going to type in the two parts of the equation. We have x squared minus 4x plus 1. Now in Desmos, you don't need the y equal to. I recommend having it just because it's proper form. It's a good habit to be in. And then you go down, x minus 2 for the second equation. Y equals x minus 2. And we can see our quadratic, we can see our line. Now, they intersect somewhere we can see in the 0.6 range and the 4.3 range. If we hover over the point, we can actually see those points. So that was a 0.69 and a 4.3. Round it to whatever Savas is telling you to round it to. If you aren't told a value, 2 or 3 decimal places is usually a good place to stop. So that's graphing and solving using Desmos. We just graph each of them separately, and we look to see where do they equal. You hover over, and it shows you those x values. All right. Next one, we have using a graphing calculator. So I have the buttons over here on the left, and then the screen is this great big piece here. Unfortunately, I forgot to hide the thing that says sharing and stop sharing, and so it's going to cover up some of the answers a little bit, but that's okay. So to enter this one, we have negative x squared plus 8x minus 13 equals absolute value of x minus 4. Couple pieces. The negative, this one's the negative. This one here is the minus. They do mean different things. Even though they mean the same thing, Mathematically, the programming, they had to be different. The minus needs something before it and after it. The negative does not. It just multiplies by -1. Up here, this xt theta n button, that's the variable button. That's what we need to use for our variables. You don't want to use this x down here because that you can actually store any number to it. It should be a 10 because the Romans discovered that x in fact equals 10. It's a Roman numeral joke if you missed that one. The other buttons that we're going to use here, we're going to have x squared for the squared. We're going to use the y equals button up here to enter our equations, the graph button to graph, the calc button we'll use, that'll be second trace. Notice it's blue. Notice the second button is blue. It's color coded. To get to the green ones, you use the green alpha button. The buttons on your calculator, if you have the same type, might be slightly different colors, but they'll still be color coded the same. So it'll be consistent. And we'll also end up using this math button here. So let's get started. All right, blinking. So to enter the equations, we're going to go up to that y equals, and then we can just type it in. We have negative x squared plus 8x minus 13. So you can see the buttons I'm type pressing. As I press them, they light up. And we can go down. This program, it jumps down a little bit. So I went back up to y2. Then we can put an absolute value. That's in the math menu. Go over to the number category, and then that first one, abs. If you have the nice new calculators, you get it in pretty print. If you have an older one, it'll say abs with parentheses. But then we can type in the x minus 4. We could graph. I chose zoom and then 6 standard so that I could see, like, make sure the window was right. We can see where they intersect. Now we go second calc. We can do the intersect feature. So down to number 5. It's going to ask for the first curve, which is the blue one. It shows us it's blue. Enter. Second curve. Jump to the red one. Enter. Then the guess. Which one are we looking for? So use the over button to get to the intersect that we're looking for. You just have to be close. Hit enter, and we can see that it's there. It's 2.69722. Or maybe that was a 3.3. To find the other one, we do the same thing. It's just our guess will be on the other one. First curve blue, second curve red. Guess. Scroll over till we get closer to the other one. Notice I'm not even getting all the way there. Hit enter. We get x equals 5.302. And that's how we can solve these equations using a graphing calculator as well. Just like Desmos, we graph both of them and we find the intersection. It's just how we do that's a little bit different. So this was section 1.5. We're just graphing using technology. That is an important skill. It does come up in pre-calculus and calculus. There are things that you are not going to be able to solve algebraically. So this is a good skill to be able to have. I'll see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.